Hello everyone, today we are going over some line 75 in C++, and today we will be focusing on product of array except self. So, before we get started, I'm just going to stick with our formulation really quick. Hang on, I just practiced this earlier. For any of these type of questions, there are 4 questions we would ask. Our input, what data structure / algorithm or technique we're going to use, and what are we going to do with the data, and then what is our output going to be. So with our following question that we have, given an integer of array nums, return an array answer such that answer I is equal to the product of all the elements of nums except nums of I. So going over that question, we've already answered our input and what our output's going to be. We are 1, given an array of nums, and our output is that we need to return an array where the answer of I for each index is equal to the product of all the elements of nums except nums of I, and the following 2 constraints that we have as listed below. The product of any prefix or suffix of nums is guaranteed to fit a 32-bit integer, and you must write an algorithm that runs O of n constant time and without using the division operation. Okay, so to be able to go over the example that we have, to understand the relationship of the question, is that we have first an array of nums, and what they want us to do is replicate this type of behavior where we have every single index that we have, each element is going to be replaced by the product of the other elements in the array. So say for instance we have the output of 24. When we mean product, we mean we are going to multiply every single number that is not the element. That's what they mean by product. So if we are at nums of 0, that's going to be 1 at the 0 index, and so 1's going to be replaced by the product of 2, 3, and 4, which is going to be 2 times 3 is 6, and 6 times 4 is going to be 24. And this relationship can also be conduced for the other ones. If we're at nums of 1, where it's going to be 2, we're going to multiply 1 times 3 times 4, which will then be 12. And then we can also just do the same for 3. So it could be 1 times 2 times 4, which is going to be 8, and 8's going to replace the 3 that's up here. And then finally for 4, we are going to replace 4 with the product of 1, 2, and then 3, which would then be 6. And this relationship can also be the same as well for each one, such as we replace -1 with the product of 1, 0, -3, and 3, which would therefore be 0. Then also do the same thing for 1, where we replace 1 with the product of -1, 0, -3, and 3, which would then be 0 altogether. And then we can also do the same for 0 at this index. We're going to replace 0 with the product of -1, 1, -3, 3, which would then be 9. And then we would have the other ones be 0 and 0, because we replaced this with the product of these numbers, and replace this one with the product of these numbers, which would therefore be 0. Okay, so we understand the relationship of what we do. So the output for when we are returning array, what is this breakpoint over here? Okay, that's weird. Okay, we return array where each, where nums of I is replaced by the product rest of the elements multiplied So we return an array where nums of I is replaced by the product of the rest of the elements multiplied. And then we will also work through our example to help break down the entire problem altogether. And so the data structure / algorithm we're going to use is called the prefix and suffix product arrays technique. So prefix and suffix product arrays technique. And some may wonder initially, and I thought of this myself, what about two-pointer? Well, I've heard of this thing called two-pointer, but isn't that the same as the prefix and suffix product arrays technique? Well, actually, no, it's not. You see, the differences between two pointers is that we're focusing on really just the whole array all of itself, and we're going to be focusing on the left and right side of the array, not particularly 2 points in the array. We're going to be scanning and creating two different arrays to be able to keep track of what we have already done. So to answer what are we going to do with the data, we are going to first create two arrays, which will then be vectors in C++, to store all the elements. Store all the elements visited. Create one array. In fact, I'm just going to put this inside of the technique so that way we know exactly what to do. Right over here. So we would first create two arrays to store all the elements visited, create one array for the left side visited, and then create one array for the right side visited. And then finally, what are we going to do with the data? We will loop through our given array, create both the left and the right side arrays, by creating a formula to take the index of each element and store them in their respective arrays, then multiply both the right and left side arrays we created for the output array. That is what we are going to do. So to kick things off, what I am going to be doing is that I will be, for step one, we will create two arrays to keep track. Is that I'm going to create a vector where it behaves similar to an array, but it keeps everything way more organized to be able to start. And I could initialize nums initially, but for the sake of clarity, I'm just going to do one and then nums.size, because we're creating a vector or array, so to speak, that's going to be the same size as num, and then I'm going to create one for the right side, and now we're going to discern the relationship between the two. So we're going to create the left array, and then we will eventually create the right array. So what we will be doing is, first things first, is that for our left array, what we will be doing is that we are going to have this relationship already set where int I is going to be 1, since we're starting off at one element. We're starting off at the element that is not going to be the leftmost, because we need to find the product of every single other element that is not going to be directly of nums of I. So we're going to multiply every single product to be able to get our output that's going to replace the index of nums of I. So then what I will be doing is then having I is going to be less than nums.size, and then we're going to increment up since we are going on the leftmost side. And the equation for us to be able to do this is that we're going to have left of I is going to be equal to, since we are focusing on the leftmost part of the array, and that we are incrementing and we want to focus on the leftmost side as well, without even going in the direct position, we will then have left of I minus 1 times nums of I minus 1. I can explain further in this example. So if we have, say this relationship, and mind you, whenever we initialize an array, it's typically going to be in ones to start with, and then for if we were to start with nums of 1, 2, 3, and 4, we will then have to take a following index. So say, for instance, left of I is going to be like the leftmost, since we are starting off at 1, we're not going to put 0, so we're going to start 1, and then we're going to have left of 1 is going to be equal to left of 1 minus 1, which will then be 0, times nums of 1 minus 1, which will then be 0, where it's going to be left 0, and then left of nums. And since we don't have anything already set in place for our new array that we're going to create, so left new array, which will then be a left of 1, 2, 3, 4 points. Yeah. it will then have to be, or hang on, nums of 0. So 0, 0. It's then going to be, since we're going to start at 1, it will have to be at least 1 to begin with. And then what we will be doing is that we are also going to be doing left where I is going to be 2. 2, 2. Left of 2 is going to be left of 2 minus 1 times nums of 2 minus 1. And we're going to refer to our array that we have already made, since we are creating a leftmost array. Since this is not the initialized one, because even though with the initialized one it will be 1, 1, 1, 1, this one is going to be a new array that we are creating, and we're just referring to the new array for future calculations as well. So we have a new array, which would therefore be left of 1 times times num of 1. It's therefore going to be, if we have 1 right here, because we started 0, 1, 2, and 3, for arrays always typically start at 0 by nature. And then we would have, so left of 1 times nums of 1, it's going to be 1 over here, and then it's going to be 2 over here to start. So 1 times 2 is going to be 2. And therefore, the left of 2 will also be 2. Yep, there we go. And so the new array is 0, 1, 2. There we go. And then we'll do the same thing for I is 3. And this should be the very end of our new array. So 3, 3, 3, 3 minus 1, nums 3 minus 1 is going to be 2, and then 2, we refer to our new array that we have already created. Alrighty, so what is left of 2? 0, 1, 2. It's going to be 2, and then we have nums of 2, where that's going to be 0, 1, 2, which would be 3. So therefore, it's going to be 2 times 3, which is then going to be 6. So therefore, left of 3 is going to be equal to 6. Just want to clarify if I got this right. Yep, okay. So it's actually going to be 6 over here, just wanted to clarify. And then given the fact that we have started at 1 and we are initializing our array, overall the new array at index 0, I'm just going to put this at the top to start. It's going to be reverted to 1, left of 0. And since we already have this formula already here, it's just really just going to be 1 to begin with. Just going to be 1. Since we've already started at 1 to start with, and we're accounting for the other size of the nums to start with. Because for the leftmost, and according to our relationship that we are exploring, we need to have the product of every other number, except every other index in our array except for the current index that we are on. So this is why we do this in particular of left of 0 will be to 1. So overall our new array altogether is going to be 1, 1, 2, and 6. So that's what we do. And now we're going to focus on creating the right side array, where it's going to have a similar behavior with the left side. It's just that the difference is the way how we treat our for loop to start with. Since we're starting with the rightmost array to begin with, it's going to be int of I is equal to num minus 2. No, it's going to be Yes, it is. It is. It is. It is. Size minus 2. The reason being is because we want the rightmost array. We want the rightmost element of our given array, and with the rightmost element of our array, typically if we want the rightmost, we go nums dot size minus 1 to find that very last one to start. But in this case, since we only want the element, we want the product of the other elements except for the element that we are on, we are doing this minus 2 because this is just in respect to the relationship that we want. We want it to be equal to the product of all the elements except of nums of I, which is why we do this minus 2 to start with. And so since we are going on the rightmost side of our given array, we are then going to have this be greater than 0 because it has to be on the rightmost. And then we are decrementing at the same time. And the relationship to begin with is, given the fact that we are doing the opposite of our left side, it's going to be right of I is going to be right of I plus 1, since we are going down, times nums of I plus 1. The reason being, I will explain this relationship further. So whenever we initialize a new array, typically, or vector to start with, what we would do, for the most part, is a similar retrospect to what we do on the left side. So I'm just going to copy and paste this and put this in here and redeclare at the same time. It's going to be right, and we have nums. So the new right array, to begin, I'm just going to get rid of the others, since what we are doing is that we are going to be focusing on the rightmost side. We will start at index of 2 because of this 2 that's already right here. So index of 2, just focusing on this example. So that would be I is equal to 2, right of 2. And since we, this formula, according to what we need to do, right of 2 is going to be equal to right of 2 plus 1 times nums of 2 plus 1, which would be equal to right of 3 plus nums of 3, to therefore be, so 0, 1, 2, 3, that would be right of 3, 0, 1, 2, 3, so that would be 1 times 4, which would then be 4. Yeah, that's correct. And then for the other ones that we will do, since we're going down our array, we're decrementing as indicated by this for loop. For this I, it's going to be 1, and then it's going to be 0. So right of 1, focusing on 1, 1, 1, 1. It's therefore going to be right of 2, plus nums of 2. And mind you, an important thing that we need to note is that our new array is always going to get updated. So that means our new array will have to be right of 2. So 0, 1, 2. It's going to be 4 to start with. And for any new number we add, we always refer to our new rightmost array. So mind you, we're bringing this down. If it's going to be right 4, the number is actually going to be 0, 1, 2, which would then be 4 times. I'm going to put this plus here. It's times, not plus, since we're multiplying the product. So it's going to be 4 times the num of 2, which is 0, 1, 2, which will then be 3, which therefore will be 12. And so therefore, right of 1 is going to be 12. So if we go in our array, 0, 1 is going to be 12. And then finally what we have for 0 is going to be right of 0. Right of 0 is going to be 0 plus 1, 0, plus 1 for nums as well. And so that would be 1, nums of 1. And mind you, we always refer to our new array that is already created for any index that we are creating, because since it's referring to the specific index that we have created while we're decrementing down inside of our array, we will then have to take each number that we have created in our new array to finally have our output eventually. So what we are going to be doing is right of 1 and nums of 1. The right of 1 is 0, 1, which will then be 12. And then, why does this? There we go. There we go. So right of 1 times nums of 1 is going to be 12 times the nums of 1, which would therefore be, going back to our nums array, is going to be 0, 1, which will be 2. Because arrays typically always start at an index of 0, and then they go all the way up. So it would be 12 times 2, which is equal to 24. And right of 0 is therefore equal to 24. And arrays typically start at 0, so we put it right here, 24, 12, and 4. And, mind you, for our third most, since we are focusing on the element except for itself, we're going to go back to our right array, and therefore our rightmost element, very rightmost overall, with right of 3, our rightmost is going to be 1, because we are referring to this rightmost array. Since the question is already stated, we want to return an array such that answer I is equal to the product of all the elements except nums of I. So we need to exclude that one last element, much like in the case of the left, where we exclude the leftmost at the same time, and we just continued up in the array according to our for loop. So that is how we do this part for the rightmost array. Now for the output, since, mind you, I want you to keep in mind about the right and the left at the same time for our array. So our output altogether, we're going to create another array, which it's going to be a vector of int. It's going to be output of nums.size. That's how we create our array to start with. And so we're going to treat this like a regular for loop. I is equal to 0. I is going to be less than nums.size. And then we'll just increment it regularly up and about. And the output of I for each index is going to be the left of I times the right of I for every single element. And it's very, very straightforward to start with. So if I were to have an output is going to be the left of I on you. Every single index is going to be multiplied from every single index of left of I and then right of I. So output would be, so say for instance we have output of 0 to start with. It's going to be at the index of a given 0. 1, 2, 3, and we want to have nums. Mind you, we have our rightmost array, our new right array, and then we also have our left array. I just want to be able to highlight this as well. New left array, new right array. So we have left array of 1, 1, 2, and 6, and then right array of 24, 12, and 1 right here, as indicated right here. And then we have our leftmost array as well, indicated right here. We're going to multiply every single one. So we have output of 0, left of I is going to be left of 0 times right of 0. So it's going to be 24. And then we can do the same thing for the other ones as well. It's very straightforward. But if you have any questions or anything else, feel free to put them in the comment section. 1, 2, 3. And the reason why we do 0, 1, 2, 3 is because we're creating an array based on the size of our nums. So if we refer to this one, it's just referring to the number of indices that we already have, which is why we do this. So if we do 1 and 1, because we replace I that way, 2 of 2, and then 3 of 3. If we look back on exactly between leftmost, so 0 right here, it's going to be 1 times 1 times 24, which will then equal 24. Then it's going to be for 1, 1 times 12, which will then be 12. Much like in the case up here, look, 24 and 12, we're getting this relationship. And then 2 and 2, which will therefore be 0, 1, 2, which will then be a 2, 0, 1, 2 at that element. It's going to be 2 times 4, which will be 8. And then we are going to have left and right of the third. So 0, 1, 2, 3, 6, and 1, which will then be 6 altogether. And so our output array is going to be 24, 12, 8, and 6. All right, so this is how we get our relationship all together. Make sure you always check every single, make sure you put every single syntax correctly. And I think this should be good. Let's run this and see if it works. But don't forget one thing, return the output, because that is what we are looking for ultimately. I just want to make sure everything is already checked. We got our edge cases as well. Let's solve this. Oh, there's some overflow going on. I think my biggest issue that I have oh wait, okay. I messed up because it's supposed to be nums of I and then 1. I apologize immensely on this front. It's supposed to be nums of I. So the reason why it's supposed to be nums.size of I and 1 is because this is how we initialize it. We don't do 1 of num size at all, because if we do that, if we had it initially before, that's a big mistake on my front. That was a big mistake on my front. I apologize on that. So it's going to be of 1 and then nums.size, because actually it's going to be the opposite right here. The reason why it's not this is because we're first initializing the size of a given array, and this doesn't really add up to anything else. Instead, we need to put we are creating at least one vector for each array that we are creating, and we're referring to the number of said arrays at the same time. So this should probably fix it. Yes, right over here. So this is how we initialize each of the vectors. It's going to be the size, and then we have 1 referring to the number of said vectors that would indicate for our arrays. So I will submit this just to double check on this. And so the time complexity for the following solution is going to be O of n, which is constant, and then the space complexity and time complexity are both going to be constant, O of n, because the reason being is we have 2 arrays that we are storing that information set in, and our solution is going to be relative to the size of our given array. So the longer the array, the constant time it would take for the size of the array to actually finish within our program. And there is a way where we can optimize this for time complexity. It's pretty stable since it's an O of n, but the space complexity, we can also further improve on this. We can do this in another technique where we can just have 1 array versus having 2 arrays to start with. So I'm just going to go back on this solution, and yes, make sure everything is already initialized correctly. And what we are going to do is that instead of doing just 2 vectors to start with, we're going to start with 1. We're going to start with just the left side to start with, and then we can actually blend this for loop, the behavior of it, for a vector output as well. Because the reason being is that we can treat the rightmost array in terms of just having 1 to start with. So what we can do is that we're going to first initialize right is going to be equal to 1 to begin with, and then we will take our for loop that we have already have and treat it as if we're going on the rightmost side to start, versus just having a standard array where we are just looping directly forward. So we can just start with nums.size, and then we're going to start on the rightmost side, have that behavior already set in place. It's equal to 0, and then we're going to decrement as well. And inside this for loop, what we will be doing is that we are going to be calling upon the relationship of right and then nums I, because the reason being is that inside of this for loop of what we will have, the right variable is going to update within our for loop and therefore be recalculated inside of our given output while we are returning our output for each index that we have. since we are creating an array already to start, you will then need to return every single index for a given output as well, right over here. And it should be optimal by keeping everything in linear space complexity, not time. Our time is still going to be constant because we're still using an array, which is a data structure, and it's storing the information while scanning every single element within our given array, and our solution will run relative to the size of a given input of our array. So let me run this really quick. Okay, we have this error because I didn't actually get rid of this entirely. We're getting rid of this entire right. Okay, something's wrong over here. I need to actually fix that. So this will be our solution overall. And make sure everything is already checked. Oh boy. Why? -1, because the problem is that we have nums of size and we're getting the rightmost array, and typically in our array we're not going to refer to nums.size. We are going to be doing this type of solution of a for loop. Int I equals nums.size -1, and then I is greater than or equal to 1, and then I is decremented. Okay, so it runs. There we go. So this is the most optimal solution. It runs in constant time O of n, and then our linear space time is, well, our space complexity is going to be linear, while our time complexity is going to be constant, O of n. And so this would be a further optimal solution as well. I have more descriptions. Let me just go back and just clear up all the rest of the pseudocode just to be able to help. Just give the clear answer all together. Right here, I just put that in for reference. There we go. So this will be our optimal solution all together. So it runs in linear. The space complexity is going to be O of 1, and the time complexity is going to be constant O of n for the most part for this entire solution that we have. We have our vector that we just use for 1. We create the left vector as well, and then we have a vector that will then be our array that we return at the same time. And make sure that all of your code is already cleaned up prior to. At the same time, look for small syntax errors as well. During that, that's also another advice. Apologies if I had some errors along the way. So yeah, that's just pretty much it for product of array accept self. If you have any questions down below to further iterate on the solution, feel free to let me know. And thank you again for taking time to watch this video. Like and subscribe, and as always, take care.